Alright, welcome back everybody to another video of the UCLA Bro. And to this video we're going to be talking about how to actually draw Newman projections. And this video might be showing you guys some tricks to draw Newman projections from various angles. And a quick reminder to you guys, if you guys are still confused about Newman projections or don't know where to start, I highly recommend to watch the part 1 of this video. This is a part 2 video. But without further ado, let's get started guys. Let's do some practice problems. Alright guys, so let's talk about this in more detail now. So when you're being asked to draw a Newman projection, most of the times you'll be given two angles, two different perspectives. So you can be given this one in which the arrow points to the right, or this one in which the arrow points to the left. And these two perspectives will give you two different Newman projections. And I'm going to show you guys a trick right now. That way you guys don't have to visualize the bonds rotating in your head, because I know that can be a little bit difficult. So this trick is going to help you guys draw Newman projections without having to do that. So let's talk about this one now. If the arrow points to the right, so for that one, your wedges are always going to be on the right side and your dashes are always going to be on the left. And for this arrow now, the one going to the left, this time your wedges are always going to be on the left. And you will guess that by now, your dashes are always going to be on the right. So let's draw the Newman projections now, so you guys can see what I'm talking about. So always start drawing your Newman projections with the back carbon, which is that circle, and that will make it a lot easier to just draw the Newman projection a lot more quickly. So now that we have our back carbon, let's draw our front carbon, and let's start with this one now. So from that direction, start with our front carbon right there. So we can see that directly down is a CH3. So for a Newman projection, directly down, it's going to be a CH3. Let's continue. We can see our hydrogen is on a wedge, and wedges go to the right. So our hydrogen is going to go to the right. Let's now look at our fluorine. Our fluorine is on a dash, so it's going to go to the left. So in our Newman projection, it's going to go to the left. Let's not look at the back carbon now. So this one right here, we can see going directly up is a CH3. So for our back carbon, directly up is a CH3. We now have a hydrogen on a dash, so that's going to go to the left side. So it's going to be a hydrogen to the left in our back carbon. And finally, we have our fluorine this time. It's on a wedge, so it's going to go to the right side. So our fluorine is going to go to the right side. And this is going to be our Newman projection for this molecule right here. Let's now look at the other one. So, same thing again. First, draw your back carbon. And now let's start with the front carbon, which is right here. So we can notice again that going directly up is a CH3. So for our front carbon, directly up is a CH3. Now, this time our hydrogen is on a dash. And remember, from that perspective, dashes go to the right. So our hydrogen this time is going to go to the right for our front carbon. Our fluorine is on a wedge, and this time wedges go to the left. So our fluorine is going to go to the left side. like that. Let's now look at the back carbon. So directly down is going to be a CH3. So it's going to look like that. Now, our hydrogen this time is on a wedge. So it's going to be going to the left side. So it's going to look like that. And finally, our fluorine is on a dash. So it's going to go to the right side. And it's going to look like that. And this is our Newman projection for that molecule right there. And notice that although we have the same molecule for both of the problems, we have different angles in which we're asked to draw the Newman projection. And for that reason, we're going to have two different Newman projections for both of the problems. And remember that this is a trick right here that you can use to draw those. And let's now look at more problems to reinforce what we just learned right now. Alright guys, so another thing that I want to show you guys, or another trick that I want to talk about, is how to know if your Newman conformation, or your Newman projection, my bad, is going to be staggered or eclipsed. So let's first talk about what staggered and eclipsed Newman projections are. So we can see this one right here looks very familiar because it looks like a Newman projection that we've been drawing so far. And that's because we've been drawing staggered Newman projections. So staggered Newman projections are always going to have bonds at 60 degrees. On the other hand, eclipse conformations like these, our bonds are basically on top of each other, and they're basically right next to each other, so their degree is 0, and that's because they're on the same face. So let me show you guys how to know if a Newman projection is going to be staggered or eclipsed. So if we have a staggered Newman projection, we're going to have this trans conformation in our molecule. And on the other hand, if we have an eclipse Newman projection, we're going to have this cis conformation in our Newman projection. And you're going to learn in organic chemistry that cis and trans could also be E and C. And one way that you can remember E versus C, or what's the difference between both of them, is remember C stands for same side. And I know that's not how you spell same, but in organic chemistry, C is for same side. So you can remember that they're on the same side. So let's draw the Newman projections now to show you what I mean. Alright, so let's say that we're told to draw the Newman projection from the angle right there. The first thing that we always want to do is draw our back carbon. So draw in the circle. Alright, so now we can draw our Newman projection. So from our front carbon, for this one right here, we can see that directly down is going to be a CH3. And from this direction, remember that our wedges will be to the right and our dashes will be to the left. So our CH3 right here is on a wedge, so it's going to be going to the right. On the other hand, our hydrogen is on a dash, so it's going to be going to the left. Alright, let's look at the back carbon now. We can see that directly up is going to be CH3. So it's going to be looking like that. Our hydrogen is on a wedge, so it's going to be going to the right. And our CH3 is on a dash, so it's going to be going to the left. And this our Newman projection, and notice again that it is staggered since the bonds are in a 60-degree angle away from each other. Let's now look at the other one, which we predicted is going to be eclipsed. So let's see if we're right. So from our front carbon, we can see directly down is going to be a CH3. And to the right would be a CH3 as well. And to the left would be a hydrogen. Let's now look at the back carbon now. So again, directly down is going to be another CH3. But notice we already have a CH3 going down. And there's a sign that our confirmation is eclipsed. So we'll draw it eclipse. And it'll look something like this. Like that. And we draw the dashed lines to represent that both of the CH3s are in the same phase. So let's continue. Our hydrogen is on the right, but notice we have our CH3 on the right as well. So we're going to draw the dashed lines again to represent that they're on the same phase. And finally, we have our CH3 going to the left. And there you go, that's our Newman projection, and we can see again that in this case it's actually eclipsed. So that confirms our trick. Remember that if they're in a cis conformation, or C for same side, they're going to be eclipsed. But if they're on a trans conformation, or E, they're going to actually be staggered. So remember that trick when you do Newman projections and problems. And let's actually do some problems now to close off the video. Alright guys, let's do some practice problems now. And I encourage you guys to pause the video right now if you guys want to give these problems a shot. And I know they might look a little bit complicated, but don't worry, we're going to be going over them. So just try your best and try to solve them, and we're going to go over them right now. Okay, so let's start with this problem now. So I know that it looks a little bit complicated, but let's run down some steps to hopefully make it a lot more manageable. So first of all, do we think that this Newman projection is going to be staggered or eclipsed? And from the confirmation that we have right here, it's a trans confirmation. So we can predict that it's going to be a staggered Newman projection. So let's actually draw it now and see if we're right. So the first thing you always want to do is draw your back carbon. And the second thing I always want you guys to do is to always draw the attachment that is not a wedge or a dash. In this case, for our front carbon, we have an HO. So always draw that first. Alright, since we are looking at the Newman projection from this angle, with the arrow going to the right, we know that our wedges are going to be on the right side and our dashes are going to be on the left. So let's draw them. So to the right is going to be a CH3, and to the left it's also going to be a CH3. Let's now look at the back carbon. Directly down is this weird structure, and for Newman projections you could draw it in two ways. It kind of depends on your teacher, but I'm gonna show you guys the two ways, and you guys can decide for yourselves. So you can just draw the molecule like that, going directly down as we see here, and that's perfectly acceptable. But if not, it does not apply for your class. You can also write down the formula. So now we know that there's two carbons right there, and there's a hydrogen right here and right here, and there's three right here. We know that this is going to be a CH2 CH3. since there's a carbon with 2 hydrogens and a carbon with 3. Alright, let's continue. So our OH is on a dash, so it's going to be going to the left. And finally, our CH3 is on a wedge, so it's going to be going to the right. And this would be our Newman projection for this problem. Let's now go into our next problem. Alright guys, so let's look at this problem now. We can see that this problem looks a little bit weird since it doesn't have any dashes. So how do we actually draw this problem then? Another trick that I want you guys to remember is that whenever there are wedges or dashes missing in your problem, you can always assume that they're going to be hydrogens. So we can see in this problem, we're missing our wedges, or dashes I mean. We can assume that these dashes that are missing are hydrogens. And with that information, we can now solve for a Newman projection. And let's ask ourselves again, do we think this is going to be a eclipse or a staggered conformation? And we can see that from the conformation here, it looks like it's a trans or a E conformation. So we predict that it's going to be a staggered Newman projection. So let's see if we're right. The first thing we always want to do is to draw our back carbon. And this will make drawing Newman projections a lot more quicker and faster. And again, remember to always draw the attachment that is not a wedge or a dash for a front carbon. And we can just draw it like this, how it appears. But if you do not want to draw it like that, we can also write down the formula. So let's break it down. We know that there is a carbon right here, a carbon right here, a carbon right here, and a carbon right there. We know this carbon doesn't have any more hydrogens, so it would just be a C. And these 3 carbons would be CH3s, so those would just be CH3s, and there will be 3 of them. So that's how we will write that molecule down. Now, remember that we now have a different angle. Our arrow is now pointing to the left. So this time, our wedges will be going to the left, and our dashes will be going to the right. Always make sure that you pay attention to what direction our arrow is going to, since you do not want to write the wrong wedges and dashes in the wrong direction. So let's continue. Our CH3 is on a wedge, so it's going to be going to the left. Our hydrogen is on a dash, so it's going to be going to the right this time. Let's now look at the back carbon. Directly down is going to be a CH3, so we can just draw that down. Our hydrogen is on a dash, so it's going to be to the right this time. And finally, this word molecule, which we've seen before, that would be a CH2, CH3. Or we could also draw it like this. Either would be acceptable. And remember, we know this since there's a carbon right here, a carbon right here, and this one has 2 hydrogens, and this one has 3. And this will be our Newman projection for that problem. Alright guys, so let's look at our final problem now. So, is this Newman projection going to be staggered or eclipsed? And we can actually see now that from our conformation here, it is a cis conformation, or a C for same side. So we can predict that this Newman projection might actually be eclipsed. So let's actually solve it now and see if we're right. So remember, first of all, you always want to be drawing your back carbon. There you go. And we can see directly up for our front carbon is going to be a fluorine. And we're looking at the angle with the arrow going to the right. So our wedges are going to be on the right and our dashes will be on the left this time. So our CH3, which is on a wedge, will be going to the right. And this might look a little bit complicated, but let's break it down. It's going to be going to the left, and you can draw it like that as well. That's perfectly acceptable. But if you want to write down the formula, we know that there's going to be a CH3 right here, and it's attached to an oxygen. So we can just write it down as oxygen CH3. That's perfectly acceptable. Let's now look at our back carbon. We can see directly up is going to be CH3, and directly up was our fluorine. So this confirms that our Newman projection is going to be eclipsed. So we're going to have a CH3 in the same phase. And to the right would be a fluorine. And since we know it's eclipsed, we can draw it like that. And finally, from our last tip that we learned, we're missing a dash. And we can just assume that that's actually just a hydrogen, like that. And since it's on a dash, we can confirm that it's going to be on the left side. So we can just draw it like this. And there you go. This is going to be our Newman projection for that problem. And this concludes our video now. Hopefully you guys enjoyed watching this video. Hopefully you guys learned something new. If you guys want me to do another video with more practice problems like these, I would be happy to. Just let me know down in the comments. And hopefully you guys enjoyed. So I'll catch you guys in the next one. And see you guys.